Hello dear students, today we will continue the very same exercise, that is exercise 11.7. So today we will see the first question for the day is question number 32. So let me read out question for you. So question says, find the equation of the perpendicular dropped from the point -2, 3 to the line x minus 4y plus 7 equals to 0. Okay, so this is the first question. Second part is also there. Second part says also find the coordinates of the foot of the perpendicular. Now let's try to understand what is the meaning of this question. So question says there's a straight line. Okay, so there's a straight line and this line is given to be x minus 4y plus 7 equals to 0. Okay, and you are dropping a perpendicular from the point -2, 3 to this line. Okay, so let me draw -2, 3. So if this is my -2, 3, then from here you are dropping a perpendicular to this line. Okay, so that means this is my perpendicular. Okay, so question says find the equation of this perpendicular line. Okay, so this is my first part, and second part says also find the foot of the perpendicular, coordinates of the foot of the perpendicular. So basically, see, this is the perpendicular and what is the foot of this? This is the foot, isn't it? And you have to find what is the coordinate of this as well. Alright, so there are two parts. So let us see the first part, that is to find the equation of this perpendicular. Now, if you see here carefully, this is a line perpendicular to this line, isn't it? So to find the equation of this, let us see what will be the equation of a line which is perpendicular to this. Okay, so the given line is, okay, so since this line is perpendicular to this, okay, the equation of any line perpendicular to this will be of the form, okay, so okay, so it will be of the form, see, this is my A, right? So ax plus by plus c equals to 0 is given, and the line perpendicular to ax plus by plus c equals to 0 will be bx, right? So what is b here? B is -4, so -4x, that is bx minus ay minus a, and how much is a? A is 1, so that's why it will be only y out here, plus lambda equals to 0. Okay, so let me call this as equation 2. Now basically this is the equation of this particular line, but we don't know the value of lambda, so we need to find what is the value of lambda. Okay, so as this line, okay, so this line passes through -2, 3, we can substitute the value of x as -2 and the value of y to be 3, isn't it? Okay, so as 2 passes through -2, 3, we have, okay, so we have, instead of x I am writing how much? Instead of x I am writing -2, and instead of y, okay, instead of y I am writing 3, okay, plus lambda equals to 0 from here. Let us evaluate and find the value of lambda. So minus into minus is plus, 4 into 2 is 8, minus 3 plus lambda equals to 0. So from here lambda turns out to be -5. Okay, so therefore from 2, the equation becomes -4x minus y, and lambda is -5 equals to 0. In order to get rid of minus sign, we will multiply both sides by minus. Okay, so after multiplying both sides by minus, I will get 4x plus y plus 5 equals to 0. So this is the equation of this particular line. Okay, so question says, another part says find the foot of the perpendicular. So basically if you see here carefully, is this the point of intersection of this line and this line? Yes, so this is the point of intersection of this line and this line, right? So let me call this as equation 3 for now. Okay, so we'll find the point of intersection of what? point of intersection of 1 and 3. Alright, so I don't have space out here, so you may pause the video to note down. Okay, so the intersection of 1 and 2 is given by this particular formula, right? Okay, so this is my 1, remember, this is my 3. Okay, so here we need to find what is C, A1, B1, C1, A2, B2, C2. So from here, A1 is 1, B1 is -4, C1 is 7, A2 is 4, B2 is 1, C2 is 5. Alright, so if you know this much, so let us put the values out here. So we have B1. How much is B1? B1 is -4. Okay, B1 is -4. C2. How much is C2? C2 is 5. Okay, C2 is 5 minus B2. How much is B2? B2 is 1. Alright, and what is C1? C1 is 7. Okay, divided by A1. A1 is this one. Okay, so remember this is A1, B1, C1, this is A2, B2, C2. So A1 is 1, B2 is 1 minus A2. A2 is 4 and B1 is B1 is -4, right? Okay, so let me check once again. So we have B1, C2, B2, C1. Okay, so A1, B2, A2, B1. Okay, fine. So here, since the denominators are same, so I'll write down this part first. So we have 4 into -4. Okay, so it is C1. C1 is how much? C1 is 7. A2 is 4 minus C2. C2 is 5 into A1. A1 is 1. Let us simplify this. So we have this is -20 minus 7 by 1 minus into minus plus. This is 16, comma. So this is 28 minus 5. Again 1 plus 16 out here. So how much is this? So this is -20 minus 7 is -27 by this is 17. Okay, comma. So this minus this is 23. So it is 23 by 17. Okay, so this is the point of intersection. Okay, so this point is how much? This much, and this will be the foot of the perpendicular. All right, so at last you write, therefore foot of the perpendicular is -27 by 17, comma 23 by 17. So this will be my answer for this particular question. So you may pause the video to note down. Okay, let's have a look at question number 33 now. Let me read the question for you. So question says, find the image of the point 1, 2 in the line x minus 3y plus 4 equals to 0, assuming the line to be a plane mirror. Okay, so the condition is somewhat like this. So there is a line given to you, and what is that line? That line is x minus 3y plus 4 equals to 0. Okay, and this line is acting like a plane mirror for you. Okay, so this is your plane mirror. Now you are reflecting a point, okay, and that point is what? That point is 1, 2. So if this is my 1, 2, then we know that when it is placed in front of a mirror, you will get an image being formed, and we know that that image will be formed in the exact distance. For example, if the distance of this object, that is this point, from the mirror is 10 units, then the image will also lie in the same distance, that is this point, this distance has to be exactly 10 units. Okay, so basically we need to find what is the coordinate of this, and you need to remember that we always measure the distance of the image and the object from mirror in a perpendicular way. That means this has to be always a perpendicular. So basically if you see here, this is also like the problem which we did just earlier to this. Okay, so basically here we'll find the foot of the perpendicular. Okay, and that foot of the perpendicular will lie exactly on the mirror line. All right, and you have to find what is the coordinate to this, but we don't know what is the coordinate of this, so that's why we'll write this as alpha comma beta. And it will be obvious that this foot of the perpendicular will lie exactly in the midpoint of 1, 2 and alpha, beta. So using midpoint concept, we are going to find the value of alpha and beta out here. So before that, we'll quickly find what is the coordinate of the foot of this perpendicular. Okay, so as you can see, the foot of the perpendicular in the same way, okay, so nothing is new, so everything is the same. So the foot of the perpendicular turns out to be 11, 10, 17 by 10. Okay, so you may pause the video to note down if you haven't done. So okay, now let alpha comma beta be the image of 1 2 through the mirror line 1. So as we have already seen, so we know that the foot of the perpendicular will be the midpoint, right? So that's why I can write 1 plus alpha whole divided by 2 must be equals to 11 by 10. So therefore 1 plus alpha whole divided by 2 will be 11 by 10, and we have 2 plus beta whole divided by 2 will be equals to 17 by 10. Okay, so we have 2 1s are 2, 2 5s are 10, so 2 1s are 2, 2 5s are 10. So we have from here alpha will be equals to 11 by 5 is there, yes, so 1 goes over there, becomes minus 1, and similarly we have beta will be equals to, we have 17 by 5 minus 2. Okay, so this 2 goes over there, becomes minus 2. So from here, what is the value of alpha? So alpha turns out to be 5 into 1 is 5. So 11 minus 5 is 6. So it is 6 by 5. And what is beta? So beta turns out to be 5 into 2 is 10. So 17 minus 10 is 7 by 5. So we got the value of alpha, we got the value of beta. Therefore, the image is alpha comma beta. And what is alpha? Alpha is 6 by 5 comma beta is 7 by 5. So my image will be this particular coordinate. Okay, so you may pause the video to note down. Okay, so dear students, now let me take question number 35. 35 says find the area of a triangle formed by the lines. Okay, so there's a triangle, and we know that a triangle is formed using 3 straight lines. Okay, and the equation of all the 3 are given. Okay, so let me call this as first equation, this is my second, and let me call this as third equation. Okay, so the given equations are, okay, so the given sides of the triangle are this one. Okay, so one is this one, number 2 is this one, and third side is represented as this equation. Fine. So question says find the area of this particular triangle, and we know that we will be able to find the area of a triangle only if we know the coordinates, that is x1 y1, x2 y2 and x3 y3. Okay, so that's what we are going to find here. That means the point of intersection of 1 and 2 is going to be my A. Okay, point of intersection of 1 and 3 is going to be B, and point of intersection of 2 and 3 will be my point C. Okay, so we'll find coordinates of A, B and C. Okay, so let us find what is the point of intersection of 1 and 2. Okay, so point of intersection of 1 and 2 is given by A, and here formula says, so let me write the denominator first. This denominator contains A1, B2, so we are talking about only these two. Okay, so this is my A1, B1, C1, A2, B2, C2. Okay, so denominator says A1, B2, so A1 is 1 into B2, B2 is minus 3, minus A2, A2 is 1 into B1, yes, so B1 is 1 out here. All right, similarly the same thing out will come out here as well, so we'll write the same as well. Okay, so here we should have B1 C2 minus B2 C1. So B1 is 1 into C2, C2 is minus 2, minus B2 is minus 3 into C1, C1 is how much? C1 is minus 6. Okay, now here we have C1 A2, C1 is how much? C1 is minus 6 into A1 is 1 minus C2 is how much? C2 is minus 2 into a1 is 1. Okay, so let us simplify this. So we have a is, so this is minus 2, okay, so see here carefully, this is minus 2, minus into minus is plus, so 16 into 3 is 18, so this is minus 18, okay, so minus 18 minus 2 is minus 20 by, so this is minus 3 minus 1, so how much is that? This is minus 4, okay. Similarly we have this is minus 6, this is minus into minus is plus, so 2, so this is minus 4 and denominator is minus 4 as you can see. That is, so after cancellation what will be the coordinate of A? It is this and this gets cancelled, so this will be 5, this and this gets cancelled, so this will be 1. So the coordinate of A is 5 comma 1. Okay, so you may pause the video to note down, and similarly you have to find the coordinate of B and C. So pause the video to note down. Okay, so now the point of intersection of 1 and 3. So forget about this equation 2. So this time this becomes my A1, B1, C1. This becomes my A2, B2, C2. Okay, so formula says B1, C2. So B1 is 1 into C2. C2 is 2 minus B2. B2 is minus 3 into C1. C1 is minus 6. Okay, so denominator contains A1, B2, A1, B2. Minus A2 B1. So as the denominator is going to be same, so 1 into minus 3 into minus 5 into 1. Okay, so here we have C1 A2 minus 6 into 5 minus C2 A1, that is 2 into 1. Okay, so let us evaluate this. So we have B is 2, again this is 18, so minus 2, minus, this is minus 18, right? So minus 18 plus 2 is minus 16 by, okay, so how much is this? This is minus 8, isn't it? Okay, so similarly here denominator will be minus 8, here this is 30 minus 30, minus 2 is minus 32. That is, after cancellation you will see that B is 2 comma 4, right? So this is my 2 comma 4. Okay, so pause the video to note down. Okay, so the point of intersection of 2 and 3 in the similar way. So you have to use 2 and 3, find it. So it turns out to be minus 1 comma 1. So this is my minus 1 comma 1. So minus 1 comma minus 1. So we have founded all the vertices of this particular triangle. So we need to find now the area of the triangle, and after that we need to find what is the centroid of the triangle as well. Okay, so let me erase this part, so you may pause the video to note down. Okay, so in order to find area of the triangle, let me call this as x1 y1, x2 y2, and let me call this as x3 y3. Okay, so therefore area of triangle ABC. Okay, so this means area of triangle ABC is equals to, so formula is simple, right? So you'll put modulus sign out here. So if you write x1, so first write x1. I hope you remember this, right? This rule. So 1, 2 and 3. So you have to follow clockwise direction. So if you write x1, then you have to write in bracket y2 minus y3. Okay, then you have to write plus x2, then in bracket y3 minus y1. Okay, so that's how you have to follow. So we have x1. How much is x1? x1 is 5. Yes, or if you want to write down the formula, that's also okay. So x1 is 5. So y2, this is y2 minus y1, y3. That's what we need to do. x1 into y2 minus y3. So y2 is 4 minus y3. y3 is minus 1. So minus into minus 1 becomes plus 1. Okay, plus x2. x2 is how much? x2 is 2. So if you write x2, then you have to write y3 minus y1. So what is y3? y3 is minus 1. Yes, minus y3 minus y1. y1 is how much? This much, isn't it? So plus, at last we have to write x1, x2 x3, right? So x3 is again minus 1. So when you write x3, then you have to write y1 minus y2. So what is y1? y1 is 1 minus what is y2? y2 is 4, isn't it? So this gives you the area of the triangle. So let us evaluate how much is this. So half, so this 5 into 5 is 25. So this is minus 2, so minus 4, this is minus 3, yes, so this is minus 1, so this is plus 3. Okay, so we see that this is equals to half into, this is 25 minus 24, I'm sorry, 25 minus 4 is 21, plus 3 is 24, right? So this is actually positive, so that's why I am removing the modulus sign from here. So after cancellation, how much will you get? You will get this to be equal to 12. So since this is your area, so that's why you will write square units. So therefore the area of this particular triangle turns out to be 12 square units. Okay, and now next part says find the centroid, and we know what is the formula of a centroid. So therefore centroid will be equals to, you know the formula is x1 plus x2 plus x3 whole divided by 3, right? So x1 is 5, so it is 5 plus x2 is 2 plus x3 is minus 1, okay, whole divided by 3, y1 that is 1 plus y2 plus y3, yes, divided by 3, that is or equal to, so how much is this? This is 5 plus 2 is 7, minus 1 is 6, by 3 is 2, okay, and how much is this? This is 5 minus 1, 5 minus 1 is, or you can cancel this too, so this is 4 by 3, okay. So that's why your centroid for this particular triangle will be 2, 4 by 3. So you may pause the video to note down. Now question 36 says, find the coordinates of the orthocenter of the triangle whose vertices are minus 3, 1, 2, minus 1 and 0, 0. So I have already explained to you about orthocenter. So I have already drawn the diagram for you. So there is a triangle whose vertices are minus 3, 1, 2, minus 1 and 0, 0. Okay, so you have to find the coordinate of the orthocenter, and we know that to draw orthocenter what we need to do is from every vertices you have to draw a perpendicular. So from this vertex I have drawn this perpendicular, as you can see, yes, and from this I have drawn this, okay. So from here also we can draw, and we know that this perpendicular will also get intersected at the same point. So that's why instead of taking the third one, so let us talk about only these two perpendicular lines, okay. So this point of intersection needs to be found. So before that we need to know what is the equation of this line and what is the equation of this perpendicular line. Now in order to find the equation of the lines, we need, one is slope and one is the point through which the line passes. So if we know slope and the point through which the line passes, then we can use this formula, isn't it? So y minus y1 equals to m into x minus x1 in order to find the equation of the line, okay, fine. Now here if you see carefully, let me write this as A, let me write this as B, and let me write this as point C. Now if you want to find the equation of this line, let me call this as B and let me call this as E. That means if you want to find the equation of AD, we know through which point the line passes, and we know that that point is minus 1, 3. So basically we need to find what is the slope of AD. Now one more thing we know is this AD is perpendicular to BC, yes, and do we know how to find the slope of BC? Yes, because we have got both the coordinates out here. So if we have both the coordinates, then we will be able to find its slope as well, okay. So we will find first the slope of BC, then we will be finding the slope of AD here, okay. Similarly we are going to do the same with BE as well, alright, fine. So this is my 36. The given points are, okay, so the given points are A, that is minus 1, 3, B, that is 2, minus 1, and C, that is 0 comma 0. Okay. So as I said, let AD be perpendicular to BC, right? So let AD be perpendicular to BC and BE be perpendicular to, so BE is perpendicular to AC. Okay. So let us find what is the slope of BC. Okay. So let us find what is the slope of BC and let us find what is the slope of AC as well. Okay. So slope of BC. Okay. So slope of BC, let me write this as M of BC. So the formula says y2 minus y1. Yes. So call this as x1 y1, call this as x2 y2. Okay. So formula says y2 minus y1, that is 0 minus of minus 1 divided by x2 minus x1, that is 0 minus 2. And how much is this? This will turn out to be exactly minus half. Okay. So this is the slope of BC. Now we know that AD and BC are perpendicular to each other. So that's why the product of their slopes has to be equal to minus 1. Okay. So as BC or AD is perpendicular to BC, okay, so product of slopes, okay, that is slope of AD into slope of BC will be equals to minus 1. Okay. So from here we will find what is the slope of AD, and after that we will find what is the equation of AD. Okay. So from here we have m of AD, we don't know this, into m of BC is minus half equals to minus 1. So from here you see that slope of AD turns out to be how much? It turns out to be 2. Okay. So therefore equation of AD which passes through so AD passes through minus 1 comma 3 is, okay, so using this formula we have y minus y1, y1 is 3 equals to slope is how much? Slope is 2, yes, into x minus x1, x1 is minus 1. So minus into minus becomes plus. So this will be the equation. Let us write this in general form. So we have 2 into x is 2x plus 2 equals to, how much is there? Y minus 3. Get everything out here. So your general equation becomes 2x minus y plus 5 equals to 0, and let me call this as equation 1. Okay. So similarly I expect you to find what is the equation of BE as well and call that equation to be equation 2. So pause the video to note down. Okay, so the equation of BE, as I said, you have to work out by yourself. You have to get x minus 3y minus 5 equals to 0. Let me call this as equation 2. Now we found the equation of BE, we found the equation of AD. Now we need to find their point of intersection, and that will be your orthocenter for this particular triangle, isn't it? So we have A1, B1, C1, A2, B2, C2. Okay, so therefore orthocenter of the triangle is the point of intersection of 1 and 2. 1 and 2 which is given by, so the formula says B1 C2. So B1 is minus 1, C2 is minus 5 minus B2, B2 is minus 3 into C1, C1 is 5 whole divided by A1 B2, that is 2 into minus 3 minus E2 B1, B1 is minus 1. Okay, so as the denominator is going to be same, let me write down the denominator first. So we have 2 into minus 3 minus 1 into minus 1. Okay, so here C1 A2, so C1 is 5 minus E2, E2 is 1 minus C2, C2 is minus 5 into C1, C1 is, I'm sorry, C2 into A1, A1 is 2, right? So let us evaluate this. So we have minus into minus is plus 5 plus 15 by, this is minus 6 plus 1 comma this is 5 plus 10. So this is minus 6 plus 1 as usual. So this is equal to, so this is 20 minus 5, isn't it? So 20 by minus 5 comma this is 15 by minus 5. So how much is this? After cancellation you will see that this will be equals to minus 4 comma minus 3. So that's why the ortho center for this particular triangle will be minus 4 comma minus 3. So you may pause the video to note down. Okay, let's have a look at question number 39. Okay, so in this particular question, so this is going to be my last question for the day. In this particular question, you need to find in center of a triangle formed by the lines y minus 15 equals to 0, or let me note down what are the given lines. So this is 39. Okay, so basically these three lines represent three sides of a triangle. So you need to find the coordinates of in center of that particular triangle. Okay, so how to do, let us see, and before that we'll try to see, or let us see what is the formula for finding in center of a triangle. Now we know that in center is the point of intersection of angular bisector of a triangle, isn't it? For example, this line is bisecting this angle A, this line is bisecting angle B. Okay, so whenever this angular bisector gets intersected, that point of intersection is known as its in center. Okay, now let us see what is happening here. So if this is my vertex A, the opposite side to it is BC, isn't it? This BC is opposite to vertex A. So this BC is having length small a. Okay, so the length of BC is small a. Now this is my B. So side opposite to B will be AC. So that is my small b. Okay, so the length of AC is small b, and a side opposite to the C is small c, and the length of this is small c out here. Okay, so if you have the coordinate of A to be x1 y1, coordinate B to be x2 y2, and coordinate C to be x3 y3, then this particular formula gives you the in center of this particular triangle. Okay, so having understood this, we came to know that first we need to find the coordinates of the vertices, yes, and after finding we need to find the length of each side. So that's what we are going to do out here. Okay, so these are the three lines given to us. So that means we need to find point of intersection of each. For example, if I call this as 1, let me call this as 2, and let me call this as 3. Okay, so y minus 15 equals to 0 represents line AB. Okay, so that's what is the meaning. So 3x plus 4y equals to 0 represents side BC, and similarly 12y minus 5x. So since we are writing x in front, so that's why let me write this as minus 5x plus 12y equals to 0. Okay, so we need to find point of intersection. Okay, so let us find what is the point of intersection of 1 and 2, and the point of intersection of 1 and 2 is B, isn't it? So quickly find what is the point of intersection. Okay, so I'll just show you one, that is the point of intersection of 1 and 3. You'll find the coordinates of A and C by yourself. Okay, so you will draw that diagram as well in the side of the problem. Okay. Okay, so it is B1C2. See here, we don't have x, right? So we can write it 0, or let me write it as 0x plus Yes, we can write this way also. So we have b1 is how much? The coordinate of y is 1. So b1 c2, we don't have c2, right? We don't have any constant quantity out here, so that's why it becomes 0 out here. So b1 c2 means 1 into 0 minus b2 c1. b2 is how much? b2 is 4 into c1. c1 is the constant quantity, that is minus 15. All right, divided by a1 b2. So a1 is 0 into b2. b2 is 4 minus a2. a2 is 3 into b1. b1 is 1. Okay, so let me write down the denominator first. So 0 into 4 minus 3 into 1. Okay, so next is we have c1 a2, right? So c1 is minus 15 into a2. a2 is 3 minus c2. c2 is not there, so that's why it is 0 into a1. a1 is also 0 out here. So let us see what is this. So that is, okay, so this is 0, so 0, this is minus into minus is plus, so this is 60, right? So 60 divided by minus 3, isn't it? So 60 divided by minus 3 is this much, yes, comma, so this is 0, so this is minus 45 and this is minus 3. That is, so how much is this? These two gets cancelled, so this is minus 20, comma, so minus and minus gets cancelled, so this will be, isn't it? So that's why the coordinate of b turns out to be minus 20, comma 15. So you may pause the video to note down this much, and please note down the formula as well. Okay, so now our job is to find, see, okay, I'm sorry, this is 15 out here. Okay, so after I showed you this part, right, so I expect you to find the point of intersection of 1 and 3, and that will be your A, which turns out to be 36, 15, and similarly find the coordinate of C, that is the point of intersection of 2 and 3, which turns out to be 0, 0. See, after finding this, in order to make use of this particular formula, what do we need? We need A, B and C as well. Now what are A, B and C? You can clearly see from the figure, A is the length of BC, isn't it? So that's why we'll find A, we'll find B, we'll find C as well. Okay, so A will be equals to BC. So using distance formula, we have x2 minus x1 whole square. So you can call this one, this as x1 y1, this as x2 y2. So you will have, using distance formula, so we have 0 minus 15 whole square. So quickly calculate this. So this turns out to be 20 square is 400 plus minus 15 square is 225. So this turns out to be square root of 625, which is equals to 25. So the value of A is 25 for me. Okay, so similarly let's calculate what is our B. So we have B is AC, isn't it? So AC will be equals to, okay, so you can call this as x1 y1, you can call this as x2 y2. So we have 0 minus 36 square plus 0 minus 15 whole square, right? So we have 36 square will be, I guess, 1296 if I'm not wrong, and similarly minus 15 square is 225. So let's add them up. So we have 11 carried over 1 is 2, 12, 1 is carried over, so 5. Okay, so square root of 1521, if you find out, will be equals to 39. Okay, so the value of B turns out to be 39. So similarly, let us find what is our C. Okay, so C is what? C is AB, isn't it? So let us calculate what is our AB as well. So call this as x1 y1, you can call this as x2 y2, okay, or call this as x1 y1, call this as x2 y2. So we are going to have 36 plus 20 whole square plus 15 minus 15. Okay, so 15 minus 15 will be 0. So 15 minus 15 whole square. Okay, so we have this 0, right? So this is how much? 56 whole square. So we have 56 whole square plus 0 is that much itself. So this turns out to be 56. So we got our value for A, B and C as well. Pause the video to note down. Okay, now we are ready to put or use the formula for finding in-center, as we have all the necessary quantities with us. Okay, so let's make use of in-center formula. So first you will write down the formula. So after that we'll put the values. So we have AX1. So how much you say? A is 25. Yes, so we have 25 into x1. x1 is how much? x1, you can see that x1 is 36. Yes, okay, plus bx2. So b is 39 and x2 is minus 20. So this is 39 into minus 20 plus c. C is 56 into x3. Okay, so 56 into x3 is 0 divided by a plus b plus c, which is 25 plus 39 plus 56. Okay, fine. So let us find what is ay1. So a is again 25, y1 is how much? y1 is 15 plus by2. So b is 39 and y2 is 15. So it is 39 into 15 plus cy3. So c is 56 and y3 is 0. So it is 56 into 0 whole divided by again a plus b plus c, that is 25 plus 39 plus 56. Okay, so quickly calculate this, do the cancellation and see how much will be your answer. Okay, so after simplification, this full thing becomes 120 and denominator, when you add them up, you will get 120. Similarly, when you simplify this, this turns out to be 960 whole divided by this is 120. Now it's simple, so 120 and 120 gets cancelled, so it is 1, and this gets cancelled and only 8 will be left. So what is the in-center of the triangle? So the in-center of the triangle is 1, 8. So you may pause the video to note down. Okay, now having understood about orthocenter, now there will be problems based on your circumcenter as well. As you can see in the following few questions, you will see that there is a question on circumcircle. Okay, so I'll just give you the hint for how to find circumcenter. You will try the sums by yourself. Okay, so this is your triangle and you want to draw circumcircle. Okay, and in order to draw circumcircle from your class 10 construction, you know that you have to draw perpendicular bisector. Okay, see, if the points are given, then our work is very simple. It's going to be short and sweet. But if the equations of the triangles are given, if the equation of the sides are given, then you have to find a point of intersection, which we have already seen, right? So you have to find first the coordinates of the vertices. Now to draw perpendicular bisector, okay, so first you have to find the midpoint. You have got two coordinates here, so you will be able to find what is the midpoint as well. Okay, now you want to find the equation of this. Okay, see here, this is one of the perpendicular bisector. You have to find perpendicular bisector for another as well. Okay, so here also you need to find its midpoint. Okay, all this will be known, this will be known. So using these two, you have to find what is the midpoint. Okay, and wherever these two perpendicular bisector gets intersected, that is your circumcenter. Remember that. Okay, now again to find circumcenter, we need to know the equation of this line and equation of this line. Yes, okay, so to find equation of, okay, so let us take this one. To find the equation of this line, see here carefully, we should know through which point does it passes. So we know this passes through the midpoint, that is this point, isn't it? So we got our x1, y1. For the formula, y minus y1 equals to m into x minus x1. So we got the value of x1 and y1, but we need the slope of this as well. That means the slope of this. And we know that this is perpendicular to this. Yes? So find the slope of this first. Okay? So after finding the slope of this, then as I did in the case of orthocenter, you will multiply the slope of this and the slope of this, and it has to be equals to -1. So from there, find the slope of this line. Okay, so after finding slope, use this formula and find what is the equation of this. Do the same with this as well. Okay, so you got the equation of this, you got the equation of this. Okay, so find the point of intersection of this equation and this equation, you will get your circumcenter. Okay, so this is how you would find circumcenter. So I expect you to do the sums on circumcenter by yourself. Alright, so today we will do only this much, and with this we close the exercise on exercise 11.7. Okay, so please go through the solved examples as I say every day. With this we close. Thank you very much.